Hi guys. So today we're going to be talking about gas laws. So in class, we've already kind of gone over the properties of gases and how they behave and how we can measure them. But right now, I'm going to go over four specific equations that you need in order to do well on the NCFE. That's your final exam. So the very first law I'm going to talk about is Boyle's law. So Boyle's law just states that pressure and volume of a gas at a constant temperature are inversely proportional. So all that means is that as pressure is increasing, volume is going to decrease, or as pressure is decreasing, your volume is going to increase. And the key to Boyle's law is to remember that it is only applicable when your temperature is not changing. So if your temperature is changing, you cannot use Boyle's law. Here's my pointer. All right, so here's a diagram to kind of illustrate Boyle's law. So here we have a container that has 4 liters of gas in it, and right now that gas is under a pressure of 1 atmosphere. So in this case, we are measuring pressure in atmospheres. And then when we increase that pressure to 2 atmospheres, we see that our volume decreases. That's just illustrating Boyle's law, that as the pressure of the gas increased, the volume decreased. Once again, this is just another diagram illustrating Boyle's law. We see here that our pressure is being measured in kilopascals. And as our pressure is decreasing, we see that the volume of gas or whatever it is that we're measuring is increasing. So once again, they are inversely proportional, those two variables. So here is the equation for Boyle's law that we are going to talk about right now. So the main thing this equation that you need to remember is that it's P1 times V1 equals P2 times V2. Make sure you write this equation down and you completely understand it. That's what this pencil is there for, telling you need to write. So P1 is your pressure. So this is basically to read out this equation, it's just that your initial pressure times your initial volume is equal to your final pressure times your final volume. So here's an example. We're going to apply Boyle's law. A balloon is filled with 25 liters of air at 1 atmosphere. If the pressure is changed to 1.5 atmosphere, what is the new volume? So we see that our pressure is going up. So just knowing those two variables are inversely related, we know that as our pressure is going up, then that automatically means that our liters is going to decrease. But the first thing that we need to do to solve this equation is to make sure that our pressures are in the same unit. So we see that our initial pressure units is atmospheres, and our final units for pressure is in atmospheres. So we are all good with that. We don't have to worry about converting anything from atmospheres to kilopascals or millimeters of mercury. We are good. So now let's write out the variables that we know. Once again, we are using the equation P1 times V1 is going to equal P2 times V2. So our initial pressure in this problem is 1 atmosphere. Then our initial volume is 25 liters. At the end of this problem, or our final part of the problem, we see that our pressure has increased to 1.5 atmosphere. So we're trying to find the new volume. We don't know what our V2 is. So once again, we're just using this equation. And so we plug in what we know. So we know that 1 atmosphere times 25 liters is going to equal 1.5 atmospheres times our final volume, or our V2. So to solve for V2, we're just using simple algebra. So we're just going to divide both sides by 1.5. And so then we'll get that our V2 equals 17 liters. So that's the answer. And it was just that simple. Now we're going to do some other ones. I'm not really going to walk you through the next ones. I want you to kind of try them on your own. So problem 2, you have a balloon. It is filled with 73 liters of air at 1.3 atmospheres. What pressure is needed to change the volume to 43 liters? So use the same equation. P1 times V1 is going to equal P2 times V2. And so you should get 2.2 atmospheres as your answer. Just to walk back through that one, you should say that in this equation, our initial volume is 73 liters, right there. Our initial pressure is 1.3 atmospheres, so that's going to be your P1. And then we don't know what our P2 is, that's what we're trying to solve for, but our V2 is 43 liters. So to solve this equation, you'll say 73 times 1.3 divided by 43, and that's going to give you 2.2 atmospheres. All right, problem number 3. Gas is collected in a 242 centimeter cube container. So anytime you see anything cubed, that's what this 3 is cubed. That means we're dealing with volume. The pressure of the gas in this container is determined to be 87.6 kilopascals. So you see we're not dealing with atmospheres here, but you don't have to worry about changing anything because this is the only pressure unit in this problem. What is the volume of this gas at standard pressure? So you remember you need to refer to your reference table to see what standard pressure is in kilopascals. So I'll give you time to refer to your reference table to figure out what is standard pressure in kilopascals. Okay, so it's once again, we're using that equation, P1 times V1 is going to equal P2 times V2. And once you work all that out, you should get that your V2 is 209 centimeters cubed. All right, moving on to the next problem. So problem 4, just another quick practice problem again. So you have gas that's collected in a 24.2 liter container. The pressure of the gas in this container is 756 millimeters of mercury. What is the pressure? What is the pressure of this gas if the volume increases to 30 liters? So we have our initial volume, which is 24.2. We have our initial pressure, which is 756 millimeters of mercury. And we have our final volume, which is 30 liters. So we are trying to solve for our P2. And once we do that, we get that P2 equals 610 millimeters of mercury. All right, Charles' law. Yay, moving on. So this is the second law we're going to talk about. And with Charles' law, we see that the volume of a gas is directly proportional to the temperature. So that means that they both are going to increase or decrease together. Charles' law can only be applied when your pressure is constant. So if your pressure changes, you can't use Charles's law. So once again, because our temperature and our volume are directly related, we see that on this graph here that as our volume is increasing, so is our temperature. So that's why you have this graph right here. So this is our equation for Charles' law. We have V1 over T1 is going to equal V2 over T2. Make sure you know this equation. This equation is important. I meant to point out Charles' law as well as Boyle's law, and the next law we'll learn about Gay-Lussac's law. Those equations are not given to you on the final exam, so you must know these equations. I'm going to give you a trick on how you can memorize them later in class, but just make sure you know these formulas. So anytime you are using Charles' law, you must make sure that you convert your temperature from Celsius to Kelvin. So you can only use Charles' law in this class if your temperature is in Kelvin. So you may say, well, what is Kelvin? How do I figure out what Kelvin is? Well, in order to convert a temperature to Kelvin, you just take whatever it is in Celsius and you add 273. And that's it. So now you've got the Kelvin. So moving on to our first example of an equation using Charles' law. Once again, this is our equation, V1 divided by T1 is going to equal V2 divided by T2. So what is the temperature of a gas that is expanded from 2.5 liters at 25 degrees Celsius to